This is going on page 103. So today we are simplifying trig identities. We learned some basic ones. Well, we talked about some we already knew yesterday, and then we learned a couple other basic ones. So we have not done very much at all, whoops, wrong way, on here yet, right? Like this is literally all we've talked about, and this is the only ones that we've actually done anything with, right? So as we go through what we're doing right now, yes, there's a whole lot of other stuff on there. We're not using any of it yet. Even if you see something that might match, don't touch it yet, okay? We're just hanging out right here in the super basic ones right now. We good? But have this in front of you because we're going to need to look at it. All right. So we are simplifying them. They are, so it says to simplify a trigonometric expression, okay? These are expressions, not equations. An equal sign makes an equation an equation. Without one like these, they're just expressions, okay? And we're simplifying them. You cannot solve them if they're not equations. If I have something like 2x plus 3x plus 7, and I'm supposed to simplify it, I simplify that to 5x plus 7. I don't then just put an equal sign somewhere and start moving things and make up math, right? Like that's literally the best I can do. That's the kind of thing we're doing. We're simplifying, okay? So it means we're going to rewrite it as a numerical expression or in terms of a single trigonometric function. That means when we're done, after we've simplified it, we might get 1. We might get 2. We might get sine of theta. We might get cosine squared theta. We might get 3 tangent theta, but it's like one single thing, okay? We good with that? All right. And remember, we're doing this with some super basic ones so we can get the idea, because it always looks way worse than it is because it's got all this trig stuff in it. With the super basic ones so that when we add in a little by little, that we're able to just continue doing it. And then our goal is to be able to do this to actually solve equations in the end. But if we try and do it all at once, it's like way too much. All right, so a couple little side notes up here. I want to think about some things. All right, so if I have sine theta, and I do want you to write this down, sine theta times cosecant theta. Right? Sine theta, that's an expression, right? Sine theta times cosecant theta. How are those two functions related to each other? They're reciprocals, okay? When you multiply something by its reciprocal, what do you get? You get 1, okay? So if I have 2, the reciprocal of 2 is 1/2. 2 times 1/2 is 1. 5 times 1/5 is 1. That's the definition of a reciprocal, right? So I'm going to write the middle step here. Now I am going to put an equal sign, not because it's an equation, but because these expressions are equivalent. So this is equal to the sine of theta times cosecant's reciprocal, so 1 over sine theta. And since I have sine over sine, that's where I get 1 from, okay? Not saying that you have to write that middle step like ever. I just want to make sure I don't lose anybody and everybody knows where that's coming from. All right, so then if I have cosine theta times secant theta, what is that going to equal? 1, because they are reciprocals of each other. If I have tangent theta times cotangent theta, what's that going to give me? 1. So we just simplified our first 3 expressions, right? Everybody good with that? Okay. So let's look and see how this is going to work here. So we have these strategies over here. And sometimes you'll be able to look at these and kind of know what to do to start. If you don't, then these are some things you want to have in the back of your mind that are possibilities. We may rewrite using reciprocal or quotient identities. That's going to happen a lot. We also kind of want to do just one step at a time. Even though when you're solving algebraic equations, if you do 2 or 3 steps at a time, that's fine. You know why? Because you've been doing it for years and years. The very first time you learned how to solve an equation, was it a good idea for you to do like 3 steps in one? No, because you really had no idea what you were doing, right? You really kind of have no idea what you're doing with these right now, right? So do not try to skip steps. Do not try to combine them, because more often than not, that causes you to do something that's weird and wrong, okay? So step by step here. So even if we do that, we would just kind of do 1 or 2 at a time. There are some people that go about these by, okay, hang on. Okay, as I was saying, some people go about things by trying to change everything into sine and cosine. That's not the best practice overall. We may do that sometimes, but the reciprocals aren't evil. And sometimes we work purely in the reciprocals just because they work out with the identities. Okay, so don't always go try and change everything. Like, don't just make this your go-to for everything. Look for Pythagorean identities. If you have something squared in there, and you should be thinking, I might be using that. Doesn't always guarantee it, but then we're going to look at the Pythagorean identities to use those. Combine fractions using a common denominator, okay? And then break fractions apart. Now, this one can be a very, very helpful one. It's not one that is always at the forefront of your mind because that's not something we do a lot in general. You have taken a lot of fractions and put them together with common denominators, right? But we don't often break them apart. Like, that's just not in the practice that we've had. So that might be something you need to kind of remind yourself. Make sure I look for that, right? And then, of course, use factoring. Okay, so we'll kind of talk through these as we go through this stuff, and especially about the breaking fractions apart. Okay, so let's go up here. So when I look at number 1, really the first thing I usually look for is there anything squared? Because if there's anything squared, I might be using a Pythagorean identity. That doesn't mean that would be necessarily my first step. Then I look at, all right, I have 2 terms. Do I have a GCF? Because if I do, I could easily factor something out. I don't have anything squared. I don't have a GCF. I don't have any fractions. So that kind of eliminates everything except for the reciprocal and quotient identity, all right? So I know that secant, what is secant the reciprocal of? Cosine. So secant can become 1 over cosine theta. And then I'm going to decide whether or not I'm going to do anything with tangent at this point after I write that. Because I have 1 over cosine, then I have sine. So I think in this case it probably would be helpful to rewrite tangent. So I'm going to write sine theta times, now tangent becomes sine theta over cosine theta. Okay. Everybody agree with all that? Okay, so then I look here, I put this over 1, right? I have 2 terms because my terms are separated by my subtraction, yes? And I basically have 2 fractions. The second fraction, what is sine times sine? Sine squared. Okay, so that's going to become sine squared over cosine, right? So I have 2 fractions. Do they have the same denominator? Yes, they do. So I'm going to go ahead and put them together. My common denominator, oops, my shirt is writing as well. My common denominator is cosine theta. So in the numerator, I'm going to have 1 minus sine squared theta. Okay. Everybody good so far? Okay, so now I have 1 fraction, but I also have something that's squared. So look at your reference chart. Do you have something on there with sine squared? Now, there's some sine squared stuff, I think, down at the bottom. Don't look at that stuff. We're not dealing with that stuff right now. Look up at the top. What it actually says on your chart, does your chart start with sine? Yeah. So your chart says sine squared theta plus cosine squared theta equals 1. You have a few options on what you could do here. You could actually replace that 1 with sine squared plus cosine squared. That's fine. You could solve for sine squared and substitute something in for that. Or can you look at that and tell me what 1 minus sine squared equals? Cosine squared, right? If I take this 1, so cosine squared from this has to equal 1 minus sine squared. That's how you manipulate it, right? And you don't necessarily have to write it down, but you might want to so you can make sure that you get it right. Because sometimes when you try and do that, the signs are backwards, the SIGNs are backwards. And we want to make sure that we're not, making something up because we're not that familiar with it. But since this right here matches this exactly, I can make this into cosine squared theta over cosine theta. And then that's just cosine because I can reduce this with one of these, and that equals cosine theta. What questions do you have? Are we good? Okay. Number 2. So I look at number 2. I do not have, I don't have any squareds. I don't have any fractions. I don't have a GCF. So I'm thinking I'm going to go the reciprocal and quotient route. That doesn't mean take everything and change everything. Like I could change sine into 1 over cosecant. Sometimes that might be helpful. I don't know that that would be helpful right now. Maybe it would be, but I think that I'm going to try with this tangent first because I could get that in terms of sine and cosine. So I'm going to let this be sine of A plus cosine A times, then tangent becomes sine A over cosine A, right? Write it all out. Make sure you can keep up with your own work and you can read your own handwriting. Can I simplify anything? Yeah, because when I put this over 1, these cancel out. So that gives me sine A plus sine A. And don't do something weird just because it's trig stuff. What is sine A plus sine A? 2 sine A. And we are done. What questions do you have? Anything? All right, let's look at number 3. All right, so on number 3, I have cotangent squared minus cosecant squared. So again, first thing I would look at is Pythagorean. Maybe I want to make those into quotients and reciprocals, but maybe not. I don't see how that would necessarily help me right now. Let's look at and sometimes the Pythagorean stuff doesn't help you. But when you look at your chart, do you have something with at least a cotangent squared in it? Yes? Okay. Make sure you're actually looking at your chart and you can find it. That's why I'm not pulling it up. You've got to be able to find these. It says cotangent squared theta plus 1 equals what? Cosecant squared theta, right? So is 1 equal to cosine squared minus cotangent squared? Or it's not going to work out exactly the same, right? I would say the safest thing to do is this is cosecant squared substituted in right here. So I have cotangent squared u minus, I am substituting in something with more than one term, so I put it in parentheses, cotangent squared u plus 1. All right, so cotangent squared minus cotangent squared zeroes out. And what am I left with? -1. If you put 1 on something like that and you get it wrong, your issue is not trig, your issue is not pre-cal, your issue is pre-algebra, and you're not paying attention to parentheses, okay? So remind yourself of that too when you're like, oh my God, this is so hard to keep getting them wrong. Why are you getting them wrong? If you're getting them wrong because you're ignoring parentheses, I don't know what to do about that anymore. Okay, we're good? All right, so let's look at number 4. Now, sometimes in a situation like number 4, we will want to distribute, but not always. So don't just jump into a question and start distributing just because you can. Like, don't do something just because you can do it, because that's not necessarily going to be helpful. I could, and maybe I'll end up doing that, but I also want to look at what's going on in the denominator. You see I have sine x and cosine x. What is sine over cosine? Tangent. So I'm going to rewrite this next step, which you wouldn't necessarily have to, but I'm going to here, just again, so I don't lose anybody. So really this is sine x over cosine x times tangent x plus cotangent x. Right? Do you agree that that's the same thing? And it's fine to skip that step because you see that that would be tangent, but I just want to make sure you understand, again, how fractions work. So sine over cosine is tangent, so tangent x times tangent x plus cotangent x. So now I can see how maybe distributing might be beneficial to me, all right? When I distribute, what's tangent times tangent? Tangent squared. And what's tangent times cotangent? 1, because they are reciprocals of each other. So now I have squareds again. I've got tangent squared plus 1. Look at your chart. Does tangent squared plus 1 give me anything? Gives me secant squared. X. Do not forget your argument, your x, your theta, your u, whatever is being used. What questions do we have? We good? All right, good deal. All right, so let's look at number 5. Cosecant minus cotangent squared over cosecant theta. So I do have a squared, but if I take just something that's squared and I use a Pythagorean, that's going to change it to 2 terms. And with 2 different fractions, like I don't know that I want to do that right now. I might end up doing that, but I think I want to take care of these fractions first, okay? I've got 2 fractions. Usually when you have 2, you want to make it into 1. So I'm going to put cosecant over 1, and I need a common denominator. Common denominator is going to be very easy to figure out on these. What would it be? Cosecant theta. Okay? Which means that first fraction has to be multiplied by cosecant over cosecant, right? So that means that the numerator becomes cosecant squared theta. The second one is fine, so that's minus cotangent squared theta. So once again, I can substitute something in for cosecant squared, right? So in the numerator, I can say cosecant squared is cotangent squared plus 1 with my parentheses, cotangent squared theta plus 1 minus cotangent squared theta all over cosecant theta. All right? Always put parentheses around something you are substituting with 2 terms. After you do it, then you can determine whether or not you care about the parentheses. But if you don't get in the habit of always doing it, you will leave it off sometime when it's important, I promise. See it all the time. Okay, so I know my denominator is still cosecant theta. Cotangent squared minus cotangent squared zeroes out, and then 1 minus nothing, so I just have 1 over cosecant. So what's my answer? Sine theta. What questions do we have? All right. So now when I look at number 6, no Pythagoreans. If I do all like reciprocal stuff here, I'm going to have a bunch of fractions and fractions, which we cannot always avoid, but if I can't avoid it, I'm going to try. This is one of those where we're going to be able to split the fractions. So here's a little side note, because I want to make sure everybody understands what I mean by that. If we have x over 2 plus y over 2, we know that that's equal to x plus y over 2. We all agree with that? That's how a common denominator works. We should all understand that 1,000%. So we're used to going this way. But instead of this, if I give you this, it's also legal to go the other way. So I can take this and make this into x over 2 plus y over 2 because that's how it got there. Okay? Does that make sense to you? So I just want to make sure we all understand what I mean by splitting the fraction. So here, when I do that, that means I'm going to have, oh, my shirt is still writing on the board, sorry. All right, so here I'm going to have 2 fractions, both with cosecant beta in the denominator, because that's the way that denominators work. And the numerator of the first one is going to be cosecant beta. The numerator of the second one is going to be sine beta. Everybody with me? So cosecant over cosecant becomes what? 1 minus. Now, sine and cosecant are reciprocals of each other. Does that mean these cancel out and give me 1? No, they do not. What you have here is you have sine of beta over, and then cosecant is 1 over sine beta. So I have a fraction and a fraction, but I can't freak out about something like that. All right? This is a keep, change, flip situation because I'm trying to simplify this. I'm not solving for that. I'm simplifying this. So this is going to become 1 minus, I keep the numerator, sine beta, multiply it by the reciprocal, which is sine beta over 1. So this gives me 1 minus sine squared beta. And what's 1 minus sine squared? Look at your chart. What is 1 minus sine squared? Cosine squared. Okay. What questions do you have? We good? All right. So number 7. I have two fractions again. And most of the time, I would say when you have two fractions, before you worry about other things, you want to get it into one fraction, okay? So we're going to have to get a common denominator here. Common denominators, like I said, always going to be very easy, easier than with numbers most of the time. This is just going to be sine u times cosine u. Okay? So the numerator, this first fraction has to be multiplied by cosine over cosine. So I'm going to get secant u times cosine u minus, the second one has to be multiplied by sine over sine. So sine times sine is sine squared. Then what is secant times cosine? 1. Because they're reciprocals. 1 minus sine squared u over sine u cosine u. Can I cancel this sign out with one of the ones in the numerator? No, because I have two terms in the numerator there. But what is 1 minus sine squared? Cosine squared. So cosine squared u over sine u cosine u. Now can I cancel some stuff out? Yeah, I can cancel this cosine out with one of those. So this gives me cosine u over sine u. And what is cosine over sine? Cotangent. What questions we got? If you like puzzles, these are like little puzzles. All right, so let's look at number 8. On number 8, this is not a split the fraction type of situation. That is not the way denominators work. I cannot make this into tangent over secant minus tangent over cosine. We all understand that, right? Okay, you can split the numerator if we have more than one terms. We cannot split the denominator like that, all right? So instead, I'm going to have to do something else here. So I'm not splitting it. I can't put it together. I have no Pythagorean. I have nothing to factor. Really, the only option I have is reciprocals and quotients. And I could do kind of everything at once, but that's not always the best idea. I know that secant and cosine are reciprocals of each other, but it's not like the denominator becomes 1 or anything. So I think I'm going to just start with the denominator. We're going to leave the numerator alone and start with the denominator. So this is equal to tangent of alpha. Remember, that's my little fat Jesus fish there. And then secant is 1 over cosine alpha minus cosine alpha over 1. Okay? So I will definitely have fractions and fractions here, but just don't make stuff up along the way. You'll be fine. I need a common denominator in the denominator. So my numerator is still tangent alpha. The denominator of the denominator, my common denominator there is going to be cosine alpha. So this first fraction doesn't need to get multiplied by anything. This second fraction has to be multiplied by cosine over cosine. So that's going to be cosine squared alpha. Everybody good? So then, still leaving my numerator alone because I'm still trying to clean up that denominator. You really just want to do one thing at a time or you can get lost in it. Or maybe I don't need to do anything with the numerator.
This is just a reminder to take your attendance. Thank you.
What is 1 minus cosine squared? Sine squared. Okay. Now, we do know that sine over cosine is tangent, but that's sine squared over cosine. So be careful. And be very careful as you're rewriting and rewriting and rewriting that if something has a square, you leave it on there. Because that's where I see some confusion. Sometimes you get lost and you're like, I cannot do the next step. And that's because you lost a squared somewhere or something. So just be aware of that. There are a few options of what I could do here. But what I think makes the most sense to most everybody and what you would do is, okay, so now that I've got the denominator in sine over cosine, I can make that into sine over cosine also, right? So I'm going to make this fraction here where my numerator, which was tangent alpha, is going to be sine alpha over cosine alpha. And then I'm just going to rewrite this one, which was sine squared alpha over cosine alpha. Okay? I have a fraction and a fraction. It looks horrible. but it's not that bad. This now is a keep, change, flip situation. So my first fraction is sine alpha over cosine alpha. I multiply it by the reciprocal of this one, which is cosine alpha over sine squared alpha. Now, can I simplify? Yes, I can cancel out those cosines. I can cancel out this sine with one of those. So this leaves me with 1 over sine alpha, and that's equal to cosecant alpha. And like I said, there was more than one way to approach that. There's more than one way to do a lot of these, especially when they get a little bit more complicated. Keep that in mind, because when you're working with each other, which so many of you do, which is great, and I hear some great mathematical arguments sometimes, if you're arguing about who's right and it's completely different, as long as you get the same answer, you can both be right. So don't lose a friendship over it, okay? All right, are we all good so far? All right, so number 9, I want to work 2 different ways, and I don't want to do that today. So we're gonna skip down to 11. We're going to come back to the other one. So look at 11. So I do have some squared stuff, so I am thinking Pythagorean identities somewhere, most likely. But I've got some other stuff going on here, too. What do you think I could do here that doesn't have anything to do with identities? GCF, yeah, I have a GCF, right? I have 2 terms, I have a GCF. The majority of the time, if you have a GCF, that is what you want to take care of first, because that'll help you in some way. All right, so this is equal to, so if I factor out my tangent squared y, that leaves me with 1 minus sine squared y. So I can still think Pythagorean, but if I replace tangent squared with something Pythagorean, that's going to replace it with 2 terms. And I'm trying to narrow things down, right? But that second one, 1 minus sine squared, what is that? Cosine squared. So I'm going to leave this as tangent squared y times cosine squared y. And then I don't think I want to use Pythagorean anymore. Instead, I know that tangent is sine over cosine, so this is sine squared y over cosine squared y. And I'm going to multiply that by cosine squared y. And then what's going to happen? Cosines cancel out. I'm left with sine squared y. The other thing you have to keep in mind as you do these is you may go down one road that looks good to you at first, and then you may get stuck. There's a dead end. And so you need to turn around and try and take another road. If you're spinning forever on one question, leave it alone, move on, and come back with fresh eyes, okay? Because, I mean, I do that too. I like, why can't I figure this out? I come back, and I'm like, oh, my God, that was so easy. My brain just was not going there right then. Sometimes you got to come back with fresh eyes, okay? So here's what we're going to do. We're going to stop here for today. I'm going to give you your worksheets. I want you to do 1 through 4 only. Try those before Monday. Then we will finish the rest of these up. And then you'll have some time to work on these on Monday. Okay, does that make sense? But you need to really at least try these.